Okay, let's keep rolling. Using integrals with a moving object. So now we have a velocity function, right? So v is some velocity function on the interval from a to b. The change in position of the object, so the displacement of the object. We can use the position function, and we can say the position at time b minus the position at time a. That's displacement. But now we also know displacement is the signed area under the curve. So this is now equivalent to the definite integral from a to b of v of t dt, the signed area under the curve. So these two things are equivalent. Well, there's something going on here. There's a big time relationship happening here. All right, and let's talk about what that relationship is in just a few seconds. If v is non-negative on the interval from a to b, all right, meaning it lies above the x-axis, or it might touch the x-axis, then we can say that the definite integral from a to b of v of t dt is total distance traveled. The reason it would be total distance traveled is because the velocity function never goes negative. All right, so not only is it displacement, but it's also total distance traveled. If v is sometimes negative, then we can use definite integrals to find the areas bounded by the function on each interval where v does not change sign. And if we do this where v does not change sign, then the sum of these areas will tell us the total distance traveled. All right, we're going to break this down into smaller intervals. All right, what's the bottom line here? The bottom line is if we use limits to evaluate these integrals, that can be extremely tedious and time-consuming. So, how do we do it without limits? Well, we're going to do this in a user-friendly way, and we're going to start out relatively slow. We have this definite integral from 1 to 4. There are the boundaries, from 1 to 4, of this function, 2x plus 1, dx, which is going to be the width delta x of each rectangle. So what does this look like? Well, here's the graph 2x plus 1, right? It's just a linear function. On the interval from 1 to 4, it creates this trapezoid. Okay. So if I want to find the area of the trapezoid, it's 1/2 the height, base 1 plus base 2. Well, the height in this case is going to be the distance from 1 to 4, so that's 3. Base 1 is 3 units because the output at 1 is 3. And base 2, the output at 4 is 9. Right? If we put f of 4, we get 9. So it's 1/2 3 times 3 plus 9, so the area is equal to 18. So in other words, what I can say is that the definite integral from 1 to 4 of 2x plus 1 dx is equivalent to 18. Now, we didn't use, it's not rocket science to get that. We just use the area under a curve. But the purpose of this is to show you that the area under the curve is equivalent to this definite integral. All right, and that's where we're going to let you work on some activities.